equations. Uh, Quadratic equation is an equation which gives you two possible answers for a quadratic equation. Now, quadratic equation itself means the maximum power is 2. You have x square terms, x terms, and the constant term. So it's in the form of ax square plus bx plus c equal to 0. And the solution, actually, there are two solutions, as it is obvious from plus or minus. The quadratic expression gives you two possible answers, minus b plus or minus root of b square minus 4ac upon 2a. A is the coefficient of x square, b is the coefficient of x, c is the constant coefficient. Now, as you can see, there are two possible answers. Once you have to take the plus sign, and once you have to take the minus sign. So if you understand this basic thing, then all the remaining things will be easy. First of all, there are two solutions. They are kind of similar, only the differentiating or distinguishing part is this b square minus 4ac and the square root. So that has been given a special attention because that's the part which is responsible for giving two separate values for the solution. So nature of roots is primarily decided by whatever is under the square root, b square minus 4ac. We call it as a discriminant. So if they use the word discriminant, it's nothing but b square minus 4ac. So there are three possibilities now. If b square minus 4ac is greater than 0, well, that means there is something here, there is something here. So that means minus b plus something will happen, minus b minus something will happen. You will get two separate roots, and that's how the roots will be real as well as distinct, means different. Now, the second possibility is b square minus 4ac, which is the part under the square root. If that is 0, well, if this is 0, then this is 0. Square root of 0 is nothing. So there is nothing to be added and subtracted. So basically, whatever is happening here, same thing happens here because there is no differentiating part. That distinguishing or distinct part, the discriminant, since it is 0, then it is unable to provide two separate values. And in that case, you will get a real answer, which is equivalent of minus b upon 2a. But the roots will be repeated. Same root you will get twice. You don't really get two distinct root. It's not going to happen. So that's why the roots will be real. That means you will be able to find them, but they will be just repeated or same thing twice. And the last case is interesting. If b square minus 4ac is less than 0, that means under square root you have a negative value. Then in that case, you will be unable to calculate the square root of a negative number unless you go into complex number, which are not for you at this stage. They will be some time later. But you will get imaginary or complex roots, and that will be the nature of the root. That happens because if you have less than 0 under square root, you will get an imaginary number. That's why the roots will be imaginary. Now let's see a quick question. Find two numbers whose sum is 27 and product is 182. They will give you a question where you are supposed to assume something x, and then you get second number, then you are supposed to multiply. Most likely it will be multiplication because then only you will get a quadratic equation. They will not give you addition and subtraction, that is unable to create an x square term. So let's calculate these two numbers. Let's assume that the first number is x and the second number will be whatever is the leftover from 27. So that will be 27 minus x. And their product, which is multiplication, x times 27 minus x, and it has been given as 182. We'll multiply x with both terms in the bracket. 27x minus x square will be 182. Now remember, we want a quadratic equation, which is like ax square plus bx plus c equal to 0. That means we want 0 on the one side of that equation. Everything should be taken on one side. Now, I can transfer this 182 here, but since it is minus x square and I don't prefer negative x square term, so I am going to transfer everything on that side, leaving the left side equal to 0. So minus x square goes to the other side, becomes positive x square. 27x goes to the other side, becomes negative 27x. So that will be x square minus 27x plus 182 equal to 0. Now, when we can use quadratic equation because we know the value of a, which is 1, b is negative 27, and c is 182. So we have just seen the quadratic equation. We can plug in the values of a, b, and c, get two values of the solutions. Or if prefer, you can take 182 as separate value. Remember, there is nothing coefficient with x square, so you can take only 182, separate that into two parts, and the two factors come out to be minus 14, minus 13. Why I have taken minus? Because number one, both minus will give you positive product. That's one thing. And we want the middle term to be negative. So that means both numbers have to be negative. That means the middle term is now supposed to be split into two parts, which is minus 14x and minus 13x. Let's do that. Now we will concentrate on the first two terms of the polynomial and last two terms of the polynomial. From first two, I can take x common. So x minus 14 will remain in the bracket. From the last two terms, I can take minus 13 common, and x minus 14 will be remaining common. Now, the whole idea of like splitting with a particular technique, like product be last term and sum should be middle term. If you do follow this systematic process, then only you will get one factor repeated. If you randomly put two numbers here, then this factor will not be repeated, and then you will not be able to put something common. So here, x minus 14 is the repeated factor that we will take only once, and everything whichever is left over, that will be transferred to the second bracket. Let's write x minus 14 as once and x minus 13 as second. When you have a product of two terms equal to 0, that means the first term can be 0, second term can be 0, or in the extreme case, both terms can be 0. So equate the individual term with equal to 0, x minus 14 equal to 0, x minus 13 equal to 0. So x will be 14 and x will be 13. So these are the two solutions. Now, you will say, okay, I got two solutions. Well, it really doesn't matter. Either one is fine, because if you take 14 as the answer, then the second number will be 27 minus 14, which is 13. So the number will be 14 and 13. Or if you take number 13, then it will be x as 13. 27 minus 13 will be 14. So the numbers are 14 and 13, or 13 and 14. So it doesn't matter whichever answer you take. One of the numbers is going to be 13, other number is going to be 14. So that's now I strongly recommend that once you get the answer, immediately check whether these satisfy the given conditions or not. Here, the two answers which you have got is 13 and 14. Their sum 27, absolutely fantastic, no problem. And 14 times 13 is actually 182, which we have got right here. In fact, we got the 14 and 13 terms right from the splitting of 182. So that means it is satisfying both conditions. Our answer is correct. So the numbers are 13 and 14. Let's see the next chapter, arithmetic progression. Arithmetic progressions are numbers arranged in an order such that the difference between two successive terms equal to 0. Here we have some terminology. A is the first term, L is the last term, and D is the common difference, and N is the number of terms, or the location or the position of that particular term in that entire sequence. Arithmetic progression can be ascending or they can be descending. It depends upon your common difference. If it is ascending arithmetic progression, then you get D as positive value. If you get descending, then you get D as a negative value. Now, there are only two formulae. Well, some has one additional formula, which is nothing but rearrangement. Let's see them individually. What you can be asked is find the nth term. Nth term means like there are several terms appearing in sequence, and then suddenly they tell you what is the 8th term, 10th term, 50th term, and so on. So in that case, you are finding out one particular number in that entire sequence. You are not interested in like whatever happens before and after. So you are finding nth term, just one single term. And for that, the formula is nth term denoted by a suffix n, an, is equal to first term plus n minus 1d. And this is obvious because you have to always start from the first term, and you have to always jump n minus 1 time. Remember, you are already starting with the first one. So in order to reach to that nth term, you have to jump n minus 1 times, and each jump or step which you are taking is worth d. So that's how the formula comes. Now, you don't have to remember how the formula comes, but remember, it's always first term and then n minus 1 differences added. And that will give you the nth number in that sequence. Now, as opposed to that, they can ask you sum up to nth term. Here, you are supposed to take all the terms appearing up to that nth term and collect them, add them together. That would be your sum up to nth term. Remember, these two formulas are totally different. This is more like individual formula. This is like collection. Everything is grabbed together. That will be sum up to nth term. Now there are two separate formulas, but they are not really carefully observe them. Uh, Sum up to nth term will be given by n by 2, which is n is the location of the n number of terms, and twice of first term and then n minus 1d. But we know that a plus 1 minus d. So if you take 1a and if you attach to this, that is equal to the nth term. So which is nothing but the last term. It can be also written as n by 2 first term last term added together. Now, if you know the last term, you will most likely go for this formula because this is simple. If you do not know the last term, then you have two options. You can first find out the last term and then plug in into the simplified formula, or don't worry about the last term, directly use this formula, and that will automatically give you the sum up to nth term directly. So that should be your strategy for arithmetic progression. Let's see a quick example. How many three-digit numbers are divisible by 7? Now, it doesn't look like arithmetic progression question at the beginning, but remember, the divisible numbers are separated by a distance of 7. So it's nothing but an arithmetic progression. So these kind of things, three-digit numbers and all those things, they actually belong to arithmetic progression. The worst they can do is, like, instead of divisible by 7, they will give divisible by 6 or 8 or 10. So instead of three-digit numbers, they can give four-digit numbers. But the strategy should be same. Now, it doesn't matter whether you are given any number, three-digit or four-digit, or divisible by 7, 8, 9, 10, any number. The general process will remain same. Now, in that case, if it is three-digit number, attack the first number, which is a three-digit number. Now, three-digit numbers, they start with 100 and end with 999. But since we are interested in numbers divisible by 7, you may not be actually starting with 100. 100 is not actually divisible by 7. So first we have to figure it out. What is the first number immediately after 100? So that would be, is it 101, 102, and so on. So I realized that the first immediate number coming, three-digit number, which is divisible by 7, is 105. So that should be the beginning point of our arithmetic progression. 105 is the beginning point. Well, 999 may not be end point. The ending point is 994 because that's a number divisible by 7. This you have to do in your head, or take a scratch paper and check which number is divisible by 7. If they give you divisible by 5 or 10, that's super fantastic. Then, 7 is prime number, so you cannot just visualize. But if it is 10, oh, that's super fantastic. If the last digit is 0, then you don't have to worry about it. So that's kind of easier than this one. So that means now create an AP. The first term will be 105, last term will be 994. Remember, last term is now known. Remember, in the previous slide, I talked about the sum up to nth number. But here we are interested in the count rather than sum, how many rather than the total. So the first term is 105, last term is 994. Our question is, how many terms are there in this sequence? Like manually counting will be impossible. So we are going to use the concept of arithmetic progression. Let's define the terminology. We have this formula for counting n terms. And remember, A is the first term, which is 105 in our case. Then D is the common difference, which is the difference between two successive terms. Now 105 plus 105 and 112, there is a difference of 7. Similarly, 112 and 119, there is a difference of 7. And the difference is supposed to be constant. Otherwise, this will not be referred as arithmetic progression, and the whole formula is not applicable. Another way to cross-check is this thing. Common difference is 7. Why? Because we are interested in numbers divisible by 7. So divisible by whatever number and the common difference must match. If you have been asked divisible by 6, the common difference will automatically come at 6. If the divisible by 10, then the common difference will be 10, and so on. So if you are solving this question by yourself a couple of times, then you realize where are the possible locations where you can make mistake. And this is a quick check. Now, the nth term, which is the last term, 994, we are interested in getting the value of n, how many terms. Remember, we are not interested in their total or this thing. We're just interested in the count, how many terms. So we are interested in n. So we'll be using the first formula. Now, it's just a matter of substitution. Everything is known except n. So now we'll plug in the values, multiply by 7. Now this minus 7 and plus 105 can be combined, becomes 8. Will be sent to the other side. So after division, n comes out to be 128. That means there are 128 terms in this particular arithmetic progression. There are 128 numbers divisible by 7, and that's going to be your final answer.